Okay, so we're back with homework 9, factoring trinomials. And there is a little trick to factoring trinomials because what we want to end up with is four terms, just like we did when we were doing homework 8, so that we can split it in half and do this factoring by grouping thing. But we can't just pick any fourth term. It has to be very specific. And so what we're going to discuss today is this thing called the AC method. So the AC method. And so if we look at a trinomial, we can consider this to be term A, this to be term B, and this to be term C. And we call this the AC method because the way that we decide what numbers we're going to end up using, the way we do that is by multiplying the coefficient of the A term and the C term. And so in this case, A times C. A coefficient, the coefficient on Z squared is 1, and C is 18. So that makes 18. And we're going to list all the factors of 18. 1 and 18, 2 and 9, 3 and 6, 4 does not work, 5 does not work, 6 I've already got. And so now that I've got that list of all the terms, I need to select a pair of them that if I were to add or subtract them, it would give me 9. And so I cannot make 9 with 1 and 18. I can make 17 or 19. I cannot make 9 with 2 and 9. I could make 7 or 11. I can make 9 with 3 and 6. And so what we need to do is we need to split that negative 9 into a 3 and a 6. And the 3 and the 6 could both be positive. They could both be negative. One could be positive. One could be negative. It really just depends on what we need to get the job done. And so in this case, to get negative 9, I would need a negative 3 and a negative 6. And so we're going to have z to the power of 2 minus 3z minus 6z plus 18. And so it's important for us to see that negative 3z and negative 6z, if I put them together, would make negative 9. And it's also important to understand that over here, we chose the negative 3 and the negative 6 because they were factors of 18. And the way that we get 18 is by multiplying A and C. And so again, in this case, A has a coefficient of 1 and C has just a number 18. That'll be more important as we go on to later problems like number 2 that does not have a coefficient of 1 on the A term. And so now that we have this, we're going to do the da-da-da-da. This is now exactly like the problems we were doing in homework 8. So on the left, I recognize I can factor out a z. I've got z minus 3. This is always a plus. And then on the right, I could factor out a 6, which would leave me with z plus 3. Okay, and I notice that this and this are not the same, and the difference is that, oh, first of all, I forgot the negative right there. Darn it. I forgot the negative on the z, because negative 6 divided by 6 is negative 1. And so we can see that on the left, the z is positive. On the right, the z is negative. On the left, the 3 is negative. On the right, the 3 is positive. That tells me that I need to factor out a negative 1 on the right side so that these will match perfectly. If I factor out a negative 1, that goes from being a positive 6 to a negative 6. That goes from being a negative z to a positive z, and from a positive 3 to a negative 3. So I like to highlight what I'm factoring out now. I have this on both sides, so I can factor it out. So I'll have a z minus 3 on the left. And on the right, I'll have a z plus a negative 6. Now, it's not okay for us to have that plus and minus next to each other, so we just have to clean that up. We've got z minus 3 times z plus a negative makes minus 6. And so that's going to be our process for factoring a trinomial. We're going to be doing this thing again called the AC method, finding what that number is, taking all of its factors, and then finding which pair of factors we could use to make the middle term. All right. And so on to number 2. So number 2 is actually a bit of an interesting case in that with this one, all 3 of those terms share a 6. So we could take a 6 out immediately. And we would end up with something that looks like this. I'm gonna remember that I took that 6 out, but I'm not gonna continue writing it. I'm just gonna leave it sort of floating there and then remember to put it back in at the end, because it will complicate things if we don't do that. And I don't want to complicate things for you, especially with just learning this. So we're gonna pretend for now that this does not exist. And we're just going to mess with what's inside the parentheses over here separately. So we've got y to the power of 2 minus y minus 72. Now, remembering the AC method, so we've got our a term right here is a 1, and we have negative 72. So we need to do 1 times 7. That's not 72 if I divide by 6, right? Darn. Okay, that's a 12. So we need to multiply 1 times 12, which again is a times c. This is a, this is b, this is c. And 1 times 12 is 12. So factors of 12, I've got 1 and 12, 2 and 6, and 3 and 4. Now I need to figure out which ones of those could I add together to make negative 1. Well, 1 and 12 will not work because that would give me 11 or 13, depending if I added or subtracted. 2 and 6 will not work because that would give me 4 or 8, depending if I added or subtracted. But 3 and 4 will work because 3 minus 4 is negative 1. So in this instance, we have to use a positive 3 and a negative 4. And so what we're going to end up doing is splitting that middle term, just like we did on the last one, to be y to the power of 2. We need a positive 3 and a negative 4. Because again, positive 3 and negative 4 makes negative 1. Just like the row above, we would have negative 1y if we were to combine the positive 3y and the negative 4y. So now we're back to just like what we were doing on problem 8, down the middle. And on the left, I could factor out a y. Now I would be left with y plus 3. This is always a plus sign. On the right, I could factor out a 4. And I would be left with negative y minus 3. And we see on the right side again that the things in parentheses don't match because we need to take a negative 1 out on the right. And so we will divide by negative 1 on the right to make these match. Y times y plus 3 plus a negative 4, which is going to make the y positive and the 3 positive. So now our y plus 3 is going to come out here. And what was left was y plus negative 4. We do have to clean up those signs, so let's do that. Y plus 3 times y minus 4. And then if you remember, that thing I highlighted red up there and said I was going to ignore the 6 until the end, we're going to bring that 6 back into the mix now. Leaving it out for a while just helped us make sense of kind of what else we had to do. So we factored that 6 out in the beginning. This completely factored would be 6 times y plus 3 times y minus 4. Kind of weird on this one, but hopefully this is making some sense. This is the only one where we are going to have a number like 6 on the outside like that. I'm not sure if you'll run into that on Alex, but we did here today. So on to number 3. So for number 3, again we have A, B, and C. The AC method is going to tell us which pair of numbers we have to use to get that middle term, or what we need to split that -2 up into. So we will have 3 times 5. And you might be thinking, well, that's a -5 on the integral. Yes, it is, but I don't care. I just need the number, not the sign for this piece. So 3 times 5 is 15. And so I need all the factors of 15. 1 times 15. 2 does not work. 3 times 5. 4 does not work. 5 does, but I've already got it. So that's it. And we need to go through and say, okay, what pair of factors could I use to make -2? And I could try 1 and 15, but that would only give me either 14 or 16, so that's not going to work. Three and 5. If I use a +3 and a -5, I will get -2. So that's what I need to do. I need to split this middle term up into a +3 and a -5. And you'll notice that I put the 3 with the 3 and I put the 5 with the 5 just because that's going to make factoring a little bit easier. And so again, this +3 and -5 is equivalent to that -2. And so that's what we're doing. We're basically splitting that -2 up into 2 terms that we can then use on the left side of our equation and the right side of our equation to be able to do the factoring by grouping seen. So we do the da-da-da-da-da. On the left side, we can take out a 3z, which would leave z plus 1 in the parentheses. This is always a plus. And on the right side, I can already tell that I need to take out a negative number because I want that z to be positive and I want that last thing to be positive. So I'm just going to do it straight away. I'm going to factor out a -5. That's going to make a positive z and a positive 1. So now I can see that I've got a z plus 1 and a z plus 1. Those will both come out over here. And what remains is 3z plus a -5. We do need to clean up those signs. Let's do that. Z plus 1 times 3z minus 5. And that's going to be it for this one. Moving on to problem 4. Okay, and so again, we need to be doing the AC method. Here's A, here's B, here's C. A times C is going to be 14 times 3. This is going to be fun. What is that, 28, 42? I need all the factors of 42. 1 times 42, 2 times 21, 3 times 14, 4 does not work, 5 does not work, 6 times 7, and I would go to 7, but I've already got it, so I know that I'm done. Now what we need to be looking for is a pair of factors that when we add or subtract them will give us this middle term, which is 11. And so let's go searching for that. We have 1 and 42. That would make 41 or 43. That's not what we need. We have 2 and 21. That would make 19 or 23. We need 11. We have 3 and 14. And 14 minus 3 is 11. So we're going to use a positive 14 and a negative 3. So 14z to the power of 2. Again, we're splitting that middle term 11 up into two numbers. And so it's going to be a positive 14 and a negative 3. And you'll notice that I put the 14 on the left with the other 14, and I put the 3 on the right with negative 3 on the right with the other 3. I'm kind of intentionally doing that so that it will be easier for me to do factoring by grouping in just a moment. And again, recognizing that that positive 14 minus 3 would make a positive 11. And so it's equivalent, just written differently. And so now we can do the factoring by grouping scene where we do the da-da-da-da-da. And on the left, we can take out a 14z times z. 14z divided by 14z is just 1. This is always a plus sign. On the right, I notice that I want my z and my 1 to be positive, so I will factor out a negative 3. So that will make z plus 1. And I will have 14z. Oops, my bad. I need to factor the things that are common out. So we've got z plus 1. And then what remains is 14z plus a negative 3. Got to clean those signs up. Z plus 1 times 14z minus 3. Okay, that's it for number 4. Lots of factoring by grouping and wacky stuff going on today. We're on to number 5. Okay. So again, the AC method, here's our A term, here's our B term, here's our C term. A times C, we're going to have 5 times 4 makes 20. And so we need all the factors of 20. 1 times 20. 2 times 10. 3 does not work. 4 times 5. 5 works, but I've already got it. So that's all of them. We are looking for a pair of numbers that when I add or subtract them, I get 8. And I want specifically negative 8. So 1 and 20 will not do that. I would get 19 or 21. 2 and 10 will do it. I would get negative 10 and positive 2 to get negative 8. So let's rewrite it that way. Negative 5v to the power of 2 minus 10v plus 2v plus 4. And recognizing that the negative 10v plus 2 is the same as negative 8. So just rewriting that middle term so that we have 4 terms instead of 3 in our problem. And you might have noticed that I intentionally put the 10 on the left with the 5 and put the 2 on the right with the 4 because that will make it divide nicely for me. So on the left, I see that both those numbers are negative, so I'm going to actually factor out a negative 5 because I want the stuff inside the parentheses to be positive. And I also need to see that I could take out a v. So that would, if I divide by a negative 5v, that would leave v plus 2. This is always a plus. And on the right, I could factor out a 2. And so if I factor out a 2, that will leave v plus 2. And so it looks like on both sides I do have the same thing, v plus 2 and v plus 2. So my v plus 2 is going to come out here. And what's left is negative 5v plus 2. Alrighty. That's going to be it for that one. And I believe that's it for this homework assignment. It is. So here's this back in case you need it. That was awesome. Hope this was helpful, and I hope you have an awesome day.